Hello everyone, my name is Boyang Yan. Today I will present my project, Multi-Agent AI Ops for Kubernetes Cluster Management. I chose this topic because infrastructure management is still very hard in modern software systems. As the system grows larger, it becomes harder for people to monitor everything, find the real problem, and respond quickly. My project explored how a multi-agent AI system can help with this process. First, let me give a little background. Think about a large company like a bank or a cloud provider such as AWS or Microsoft Azure. Those companies run thousands of servers, applications, and network service. Every second, those systems generate a huge amount of data, logs, and alarms. For a human IT team, it is very hard to watch all of this at the same time. When something goes wrong, like a website crash, many alerts may go off together. Then the team has to check logs, dashboard, and tools to figure out what actually broken and why. This process is slow, it is stressful, it is cost money. AI Ops try to help with this. It uses AI and machine learning to support IT operation. Instead of asking a human to watch thousands of warning signals, and the AI can watch the system, find useful patterns, remove noisy, and connect related signal. So why this problem matter? In real Kubernetes incident response, operators do not work in one place. They keep switch between KubeControl, dashboard, logs, metrics, and runbook. Because of this, the evidence is distributed across many tools and server. That makes finding the problem slower. The next issue is remediations. Remediations is not always consistent because a lot of useful knowledge stay in personal notes or in people's memory. It is not always part of a shared workflow. So the goal of this project is to reduce that overhead cost. Instead of asking humans to connect everything by hand, I use a structured multi-agent workflow that moves from evidence collection to find the problem, then to give a solution. This system is designed to be a local-first Kubernetes assistant. It is not just a chatbot that reads logs. It can detect accident, collect live evidence, retrieve operational knowledge, check personal notes when needed, and then propose a remediation plan. In some cases, it can also take action safely. There are three main design choices here. First, it stays local by using Ollama with Google Gamma 4. Second, it uses language graph because the workflow has a stage, branch, and human-in-loop steps. Third, it uses hybrid knowledge access. That means graph-based browsing for personal notes and junk retrieval for operational documents. Finally, I use Minikube as a test environment. It is realistic enough for experience and also easy to reproduce. These slides show a multi-agent workflow. The workflow is divided into four main parts: observation, retrieval, deciding, and take action. This structure is important. The system can first collect evidence, then reason about it, and only action after safety check. The process starts from cluster signal, such as events, metrics. Those signals trigger incident monitor. Then the system collects live evidence and branch into three context sources: Kubernetes RAG, my own knowledge base, Algorithm, and Kubernetes GPT live analysis. Those inputs come together in the problem diagnostic stage. After that, the system moves to planning, policy check, man-in-loop, verification, and reporting. This slide shows my daemon scenario, image pull back off. In this daemon, I first reset the environment, so the cluster starts from a clear stage. Then, I manually give a bad image fault into the application. This creates an image pullback off error, which means Kubernetes cannot pull the container's image successfully. After that, I run the workflow. Finally, I identified the result in 2 ways. First, I check the saved log workflow output to confirm that the execution are successful. Second, I confirm the result directly from Kubernetes by checking the deployment stage, pulls information, and the final image. So this demo shows a full loop. The biggest current problem is my workflow takes more than 20 minutes to run. This project video link shows more details, step by step, how to run the project. Thanks you very much. I'm happy to take any questions.